It's about the top of the hour. And the last presentation today is by Lyle Simonton, who's going to talk about the impact of a geotechnical report on decision making in formal contracting. Lyle, the floor is yours.
Okay, thank you, Gerald, and thanks to the It's Money webinar committee for asking me to speak to the webinar audience today. Hopefully this presentation will be a pretty good segue from Rob's presentation. There'll be a lot of similar themes here with respect to geotechnical investigations and how we can think through those maybe a little bit differently. I'm going to give the specialty contractors, especially geotechnical contractors, perspective on that thought, and ultimately we're trying to bring value to the owner. So from the It's Money theme, the definition that I would use for testing is more just maybe a little bit broader in the case of this presentation, and that the geotechnical investigation is the test, is the testing process. So with my background in a little bit in consulting earlier in my career and about 15 years in specialty geotechnical contracting, we come across a lot of examples, and I hope that it's maybe understood at the end of the presentation is not just that these examples exist, it's maybe how frequently they come up. Certainly we talk about them a lot, and Rob's presentation alluded to geotechnical investigations and how they could be more thorough, and there'll be a lot of probably preaching to the choir going on in this presentation, presuming that a lot of the audience have a geotechnical background and are all in favor of doing more borings. But I'm going to talk about specific projects, and maybe not even, you know, they're really smaller scope projects, seemingly smaller scope than what some of the projects you've seen in the previous presentations. But go into the nuances of what we're looking at with borings and how they affect the decisions that we have to make from a bidding and design perspective as a specialty contractor. So I will touch on a few of those services that we provide. Most of this presentation will revolve around ground improvement more so than deep foundations, but certainly deep foundations are greatly affected by the geotechnical investigation and the information provided in that. Talk about the soils report. As Rob mentioned, limited information on projects, what might be well thought out or you think is well thought out in terms of the number of borings for a specific project. Even within those number of borings, the type and frequency of sampling can be very significant. So we'll go into that, and ultimately with the goal of continuing to discuss this, continuing to talk about, you know, we all talk about the commoditization of our profession. We have to continue to talk about it in these conferences, but not just preach to the choir, but also preach to our owners and our clients. So the first example that I want to talk about to get into a little bit of maybe earlier in my career as a contractor, what got me thinking about this sort of thing. As you'll see a boring here, and the geotechnical engineer did nothing wrong on this. This is an example of a boring that was done for a project, and we get a call from a general contractor that asks us to price some rock anchors. And so the first question we always ask is, do you have a geotechnical report? And sure, we have a geotechnical report. They send that over, and as many of you watching this probably quickly picked up, for rock anchors, the boring is terminated in clay. 25 feet of clay, there's no rock to be found, not to mention no rock to be found, certainly don't have any idea on the quality of rock. So as you can imagine, this sort of thing makes it really difficult to price and design, install rock anchors. But so the idea is, in this particular case, since the geotech report was done for the original structure, no harm, no foul, but more borings are going to have to be done before we can pursue any type of rock anchors on this example. Another project example of a ground improvement aggregate pier type project that came up several years ago to bid. And this was an example, this is one of 5 borings on that particular project. And I know we all were quote unquote raised a little bit differently in the geotechnical world. My background, I was best taught to describe the soils as best as I can. And I realize we don't always have the luxury of having a geologist or an engineer on a drill rig. However, this particular boring and a series of these borings provided in a report to try to bid a job is just not sufficient. A couple things I'll point out, not just the very general description of tan sand, but that particular sand with a blow count of 15 at 6 feet, 6 feet depth. What happens after that? You know, we have another 15 feet of soil that apparently was sampled and described because we know a water level. However, we don't know anything at all about soil strength below that one sample. So from a specialty contractor perspective, as we try to bid and design a job, we have to basically assume that we have 15 feet of soil that's exactly like what it said it was at 5 feet. Just for reference, I can't show all the borings here, but the other borings on the site, a couple of them just described the soil as gray clay. So we had tan sand, we had gray clay, and we really could have used a lot more indication on soil strength and soil parameters on this particular project. So geotechnical contracting, as many of you know, DFI is literally the who's who of specialty geotechnical contractors in the industry, all of which provide maybe all of these services or certainly some portion of these services. And most of my experience is in the Midwest, where happens to be a lot of drilled shafts. We install a lot of drilled shafts in bearing, in rock, often with the rock core in the drilled shaft. Don't drive a lot of pile anymore in the Midwest, but it's certainly something that we see on occasion. And then site-specific, get into auger cast and micropile. As most of you know, aggregate pier ground improvement has become extremely prevalent nationwide and really probably worldwide. What we call aggregate piers or vibro stone columns. Under the umbrella of ground improvement, as most of you know, you probably realize you need some kind of soil strength to be able to design aggregate piers for a higher bearing pressure. And when that soil strength goes way down, when the soil becomes extremely soft, such as in organics and elastic silts and that sort of thing, you're looking to put a grout into that column. And we call those rigid inclusions, or maybe vibro concrete columns, grouted columns, something along those lines. And then a lot of geotechnical contractors also do earth retention, which certainly is another service that's very much dependent upon a thorough geotechnical investigation and lab testing program. So nothing particularly unique here in terms of these slides. As you saw in Andres' presentation, lots of auger cast went into detail with describing auger cast. What's very common in the Midwest, as I referred to, in what you might see in the lower left-hand corner, drilled shafts. In this particular case, drilled shafts down to the top of rock and a rock core. Hopefully you can see with at least 2 of these rigs, there's some core barrels sitting there. In the far lower left corner, you can see some white material, white dust, and that's limestone that has been cored out of that particular shaft. So pretty prevalent there. And the takeaway from a drilled shaft perspective, I'm not going to go into a lot of detail on drilled shafts, but certainly it's important to know a lot about the rock hardness, the quality of that rock that we're trying to drill out for drilled shaft construction. Switching gears to ground improvement, just an illustration here of what we call a vibro flot or vibro probe for the installation of aggregate piers, or what we call stone columns. Those can be installed with either a vibratory probe or a tamping apparatus to compact stone in a hole. My company's experience is mostly around the installation of stone columns with forcing that probe into the ground and vibrating the stone in lifts. We can either pre-drill that hole or just jam the probe into the ground. And I'll get into a little bit more of that as we go. So from a design perspective, as a specialty contractor with aggregate piers, we are the designer on these projects. And we're looking predominantly to reach a bearing pressure and settlement criteria. So the bearing pressure component is often 5 to 6 KSF. What you see here in this illustration, and again, just an illustration, but shows a couple different soil strata. And the idea is that we're probably trying to reinforce a soft soil with the aggregate pier. And although this load does not transfer to a lower layer, you definitely want to see an increase in strength of that lower layer so you can actually build up that aggregate pier at the bottom and get good compaction on that throughout. Another component of the design, and a large component of that, is settlement. And when we calculate settlement for aggregate piers, we're using a cumulative settlement of both the reinforced zone that you see here and the settlement of the layer underneath that, or layers underneath that, which comes into play especially on heavily loaded footings, or large footings more specifically, such as in grain bins and liquid storage tanks and large mat foundations. So we need to understand this soil profile, not just within where that stone column is going to go, but also below that stone column, in particular on those types of structures that I mentioned. So again, nothing unique here with deep foundations. We certainly need to have a good understanding of our bearing strata. As I mentioned in that very first example with that boring, we had no idea where our bearing strata even was on that boring, much less the quality of the bearing strata. So rock quality is very important. We had one project, and I don't go into detail on that here just for the sake of time, where ran into chert that was unanticipated, or maybe one boring showed some chert. And you're talking about, in that particular project, an extra $50,000 to $100,000 just in core barrel teeth for trying to advance through the extensive chert that was ultimately found on the site. So dollars can get big in a hurry in the specialty contracting world. And that's what we want to try to convince to our owners and help them understand, is it's not just an additional cost on the front end of your geotechnical information. It's helping them understand the true dollars that they can encounter, or just headaches in terms of delays and things like that that can be encountered on the back end when the specialty contractor's on site doing their work. And so a lot of variables that come into play when discussing the cost of deep foundations. Certainly soil and rock type, as I mentioned. Geographical region's a big part of that. In the St. Louis areas, due to a lot of drilled shafts, don't see as much driven pile, but there are a lot of places in the country where driven pile is the optimum deep foundation. So the idea is we want to help our clients identify what is the most cost-effective deep foundation type, or in the case where we have to do ground improvement, what the most cost-effective approach is with ground improvement. So those are typically the options that we are getting involved with, and what we often see is that if we can make aggregate piers work and support shallow spread footings on aggregate piers, then that's probably the most cost-effective option. But as those loads get higher and higher and the soils get softer and softer, certainly deep foundations come into play and become the best option. And as I mentioned, with specialty foundation work, whether you're just installing or designing, the cost difference, increased cost and things like that can be very significant. If it's just a matter of adding a piece of equipment and an operator for that equipment on a job site, that can add us pretty substantial costs, and that alone could pay for additional geotech reports, 2 or 3-fold. Not additional geotech reports, but more so additional borings. So a question we get a lot as specialty contractors, and we're certainly happy to get it because somebody's calling us for our opinion, is how much would something like that cost? Now, I can tell you that we kind of joke around our office a little bit about this question, because oftentimes this question follows a description of a project. Maybe it's a number of drilled shafts or an area of a project. I have a 100,000 square foot building and we have 10 feet of soft soils. How much would it cost to put in aggregate piers? So the reason we kind of laugh about that is that, we're certainly happy to provide ballparks, but we want those ballpark costs to mean something. We want the clients to be able to make some kind of decision. And I think a lot of times when somebody asks for a ballpark, they don't realize how big that ballpark can be, and it can be so big that makes the project go away before any information was ever provided. And that's a lot of times the issue early on, is that we get this question all the time, and hardly any, if any, borings are available at all. So as Rob showed the case history where you had 2 CPTs early on, that can go a long way towards helping to budget a job and help decide if ground improvement or deep foundations are going to be the solution. And there are certainly cases where we can maybe pull borings from an adjacent site, or just rely on experience in a certain geographical area to make some decisions. But the bottom line is that the borings are just absolutely critical to everything that we do. And so ultimately, the information that we can provide is dependent upon the information that's provided to us. And the better that information, the more we can fine-tune our feasibility studies and our budgets on projects, and certainly our information on bid day. And a lot of times, even on bid day, we just don't have very much information to go on. So it makes our decisions and our risk much more difficult, and with risk more difficult to evaluate. So I touched on this a little bit already, in terms of cost considerations, things that we're thinking about as specialty contractors, whether it's a shallow foundation with aggregate pier ground improvement. A couple factors there. Is pre-drill or no pre-drill. There are cases where we can just jam the probe into the ground and install some aggregate piers. However, if the layers of soil we're going through, maybe there's some stiff layers, or what happens a lot of times is we have man-made fill, your urban fill material that has cobbles and bricks and maybe even old footings, things like that require pre-drill. And just that difference between pre-drill and no pre-drill can be a substantial addition in cost when you're sending out another rig, you're sending out an operator, you're generating spoils, all these things that maybe the geotech report didn't really encounter to the extent that we would need to make those decisions. And then again, if shallow foundations aren't a solution with ground improvement, then we're probably looking at deep foundations. So factors that affect that process, the geographical region of the project, as I mentioned, we're talking about deep foundations, how much information is available. We're looking at what competitors we might have on a job. And from an owner's perspective, the owner wants as many bidders as possible. And so if you only have 3 or 4 ground improvement contractors looking at a project, and a couple of them drop out because there's just insufficient information to look at to bid the project, that can substantially change the ultimate cost of ground improvement there. Schedule and things like liquidated damages come into play. All these things revolve around the idea of risk for the specialty contractor. So let's touch on the soils report. Nothing new here. I think I would assume that the majority of the audience is going to be in agreement that the more borings we can do, the better. I'm not telling a geotechnical consultant anything they don't know. They certainly want to do that. But ultimately, we have to decide as a geotechnical community how best to educate the owners and our clients on the importance of this. We talk about it all the time. We have to figure out how as a geotechnical community we can start acting on it, and more importantly, have our owners act on it and take our advice. I'll give some examples of where boring spacing becomes very significant. The number of borings might seem on the surface enough, but when you see really how far these things are spaced out, can become a problem, and something that Rob also pointed out with the CPTs on his project. The sampling type, we can argue all day about SPTs versus CPTs, Shelby tube samples. The idea is, from our perspective as a geotechnical contractor, is that there are times when we don't have any of these things. That boring I showed early in the presentation that didn't have any test results, any SPTs at all below 5 feet, and the boring went down to 20 feet. So we have these huge voids sometimes where we have to try to determine what's going on in the ground and what kind of soil strengths that we have. So all these types of tests are important to do, as long as we're doing them fairly frequently within that boring. And then to take that a step further with the testing component, strength testing is extremely key to ground improvement design, as I mentioned earlier with rock drilling. for aggregate pier design, we really need to have a good idea of what kind of soil strength we have around the outside of those piers, and then what kind of consolidation parameters we have within the depth of that settlement bowl. And that's where CPTs can come into play, where we get that continuous look all the way down in that within the portion that we have to analyze settlement for. So the first example I want to show here is a project in the Midwest, and let me try to explain to you what we're looking at here. If you look at the boring location plan on the right, the structure that we're bidding, in this case designing, is, I believe, a mixed-use facility, and you're looking at roughly this area as the new structure. So borings 1 through 5, B1 through B5, we're going to incorporate B2 into that. That's just outside the building footprint, but certainly close enough that we need to look at that and use that information to try to assess what kind of soil strength and soil types we have here. So on the left-hand side is a spreadsheet that summarizes these borings. Now what you're looking at with the red numbers, those are correlated SPTs. So on this particular project, all these borings, all of the samples were Shelby tube samples. So Shelby tube samples throughout that particular boring, down to about, a couple cases 30 feet, a couple cases 20 feet. And we have correlated the unconfined strength tests or hand penetrometers to SPT counts in this particular case. And so the unconfined strength test, these blue rectangles, encompass the correlated SPTs that we've taken from the unconfined test. And so if you look at a couple things here, you're going to see that the unconfined test, which we certainly want to rely on, show a lot of soft to medium stiff clay. And that's very helpful from an aggregate pier designer standpoint. But let's look at the two borings where there were no unconfined taken. These are all hand penetrometer samples. So boring 2, for instance, this one that's just outside the building footprint, that boring encompasses really a huge portion of this structure for which we have to design aggregate piers. And if we look at that boring, we have 15 feet of material here, and we only have hand penetrometers. And so we've correlated those to blow counts. And if you just look at the discrepancy in the blow counts of what's correlated from hand penetrometers here in boring B2 and here in boring B4, it's showing that the ground is really good. It's showing very stiff clay, really. And if you just looked at this boring, you probably would think, well, why are they even doing ground improvement out here? Well, then you look at actual unconfined tests, and we don't really have a lot of areas. Well, I guess you look at right in here. Obviously, the site can change, the conditions can change across the site, but do we really expect that they're just drastically different, where we have blow counts of 1 through 3 from the unconfined tests and blow counts of 12 through 18 from just hand penetrometers? And I know I'm not saying that we like to rely on hand penetrometers, but if that's all that we have from a boring, then it's hard to completely ignore that. But when you see the discrepancy between hand penetrometer results and unconfined strength testing, it really leaves some uncertainty from a design perspective, that you can go from, maybe needing very closely spaced aggregate piers in these soil types to hardly needing aggregate piers in this soil type at all. And then the question, can you really rely on that information? So another project here is a warehouse in the south, pretty good sized warehouse, where we have 6 borings, 25 feet deep. And this particular, when I say pretty good size, this yellow line, although as we transferred the slides over to a different format, kind of got out of whack here, but this yellow line is supposed to go right across here, and that's indicative of different phases of construction. So this upper portion is phase 1 of this warehouse, and later on phase 2 will be bid and constructed. And phase 1 is about 60,000 square feet, so we're looking at about 200 feet across and about 300 feet down, so roughly the size of a football field. And in that 60,000 square feet, well, really in 100,000 square feet, we're looking at 6 borings across the entire thing, phase 1 and phase 2. We have about 20 square inches of coverage with our borings. and we're trying to gain an understanding of the soil parameters in about 100,000 square feet of building footprint. So just kind of numerically showing how little information we have to go on in the grand scheme of things. And let's take that a step further and actually look at the borings. So I'm not going to show you every single boring here for the sake of time. I'm going to show you B5 first, and I can tell you that B3, B5, B3, and B1 are all fairly similar. And so I don't know how well you can see the blow counts here, but I'll read them to you. This is a 5, a 9, an 8, and then it jumps up substantially in here. So we're looking at this as a, maybe a 10-foot deep aggregate pier, pretty straightforward. We can get some pretty good loads out of that type of soil, a medium, stiff, cohesive, relatively cohesive soil. And that would be the case. Here we're talking about basically 400 feet of building on that side. So let's look at another boring here, boring B2, which isn't even in this particular phase of construction, but still we want to look at it because it's relatively close. And literally, whoa, we look at this. We have weight of hammer material from 11 feet all the way down to 17 feet. So almost no strength in this zone, which is seen in this particular boring. So certainly we want to take note of that and wonder, okay, what's going to happen in that zone? We're going to have a lot of settlement within that zone. Even if you have an aggregate pier through it, do you have enough lateral resistance in that zone for an aggregate pier to be able to transfer load into it? So let's keep looking at the borings here. We have boring 2, it has this very soft layer. We go up here to boring 4. Soft layer doesn't exist, similar to boring 5 where we have medium stiff clays throughout. The stiffer zone gets a little bit deeper here, but still relatively decent clays here. So we've now looked at 5, 4, you have to trust me on 3 and 1 that all have pretty good clays there. We look at one more boring here, B6, and lo and behold, this really soft zone shows up again. And so we're looking at B6 and B2 that are probably, 400 feet apart from one another and show this particular soft zone that's 5 feet thick. And we can't ignore that by any means, but it could drastically change our approach. Maybe we have to put some grout into these columns and make it a rigid inclusion. Whenever you're looking at this in the bidding process and you have multiple competitors looking at it the other way, the same, are also looking at it, there's really no apples to apples comparison because it's all engineering judgment on how extensive you think this really soft zone is. Because up here, we have no problems with aggregate piers, but in these other zones, how big of a deal is that settlement? And we have to completely change our technique. I wrote down the title of some of Rob's slides jumped out to me here. Different soil profiles require different solutions. Well, on bid day, it's very difficult to implement a bunch of different solutions to a project. So these are just some of the things that we're thinking about as specialty geotechnical contractors in the course of a project. I'm not going to spend much time at all on this one, just point out that this is a decent sized structure, 45,000 square feet. I'm going to point out this one boring B25. And this is another project where Shelby tubes were used as a sampling technique extensively. And on that B25, here we have about 12 to 15 feet zone where we have one unconfined test at 0.1 TSF. So again, a very extensive layer. We have to assume that the majority of this depth, or the majority of this strata is 0.1 TSF. That's literally all we have in that zone. So just to mention a couple other things we see with relative frequency. Now again, hopefully you keep that in mind that these aren't just one-offs. We see these types of things very frequently, especially geotechnical contractors, that really affect our costs and how we approach projects. Organics, for one, we see organics that can greatly affect how we approach a project. However, they're not very well described or tested often. And as we know, organics can mean anything from organic topsoil that's going to be removed from a site to literally zero strength, and it changes our technique drastically. Drilling observations and borings. When a driller's out there, even their small diameter hole and how the experience they had in drilling that hole can be greatly impactful on the fact that we're going to be drilling or implementing a larger diameter hole. We want to know what that driller experienced. Was it hard drilling? Did they encounter something and have to move the boring over a little bit? Heave from rotary wash, which we do look at that and assume that maybe there's a loss of strength there in that first SPT when switching over to rotary wash. Those types of things, those observations are very important. Test pit observations are also extremely important. We recently had a project that we were constructing and knew we'd probably have some pre-drill on the site. However, the drilling was extremely difficult. And we had some test pits from the original geotechnical investigation. And the test pits didn't indicate really any difficulty with advancing the test pit. They basically just described what type of soils the test pit encountered. Well, then further test pits were done as we were on site, and the excavator couldn't even get the bucket down in the same area. And so we presumed that when the original test pits were done for the investigation, they also had difficulty but didn't indicate it. So we had no idea that it was really difficult to advance mechanical equipment in that particular soil. And I should have pointed this out in an earlier slide. It was one example of a boring that was terminated in very soft soil. If possible in the field, if these borings could be advanced, you know, maybe it's another 5 or 10 feet, but we show that we can get that into the, we can get a little bit more information on an increased strength strata, we want to do so. So that wraps up my talk today.